Okay. Hello, everybody. My name is Isabel Peterson. I go to the University of Wisconsin-River Falls, where I study both chemistry and geology. And today I will be telling everybody about the total thermokarst lake changes on the Seward Peninsula from 2016 to 2024. First up, though, I do have to give a big thanks to all these people, as without them, I would not be standing where I am here today. So, moving on to what even are thermokarsts, because I also started from ground zero on this subject about 6 weeks ago. So thermokarst is due to the melting of permafrost. And as permafrost melts, it tends to kind of create these little divots in the land that start to accumulate water that starts to melt even more permafrost. Now, permafrost melting is a very big deal as permafrost tends to hold a lot of greenhouse gases within it, and as greenhouse gases tend to cause more climate change to happen, you can kind of see how that'd be a runaway greenhouse effect. And the thing is with permafrost is that it's hard to directly measure by satellite as it is underneath the ground, and we don't have many things that can actually penetrate into the ground to measure it. And as you can kind of see from this nice little diagram here, you can kind of see how the progression of thermokarst development and kind of how channels develop and how lakes develop. I really want to focus on these lakes as this is one of the first images I saw when I started looking at what thermokarst even is, and I saw kind of these huge lakes in the forefront. Now, I'm originally from Minnesota. I know what lakes look like, and I was like, okay, well, these are a completely different type of lake. What do they even mean? So these lakes develop due to melting permafrost, and as I said before, they grow, they start melting even more permafrost, and these lakes can also drain quite rapidly. Now, these draining of lakes can lead into channelization and more melting permafrost along channels, and these lakes can also drain, they can refill, and they can kind of go through cycles like that, leading to even more permafrost melting. So I specifically started looking up in Alaska because I was interested in working in the United States, and I'm like, well, where's a place with permafrost in the United States? That's Alaska. So I focused on this area because I found a 2011 study by Jones et al. That was looking in this area. They started in 1950 and they went up to 2007. Looking at 3 different years during that time span, and they kind of compared the lake changes over that time. It's like, well, what happens if I extend that time period to modern day and start looking more at annual changes? So this is their study area, and I want you guys really to focus on that red-lined area, as it's really has a bunch of that green area, which is where thermokarst is, kind of within it. So when I started looking for the data that I really wanted, I found that the Harmonized Landsat Sentinel-2, so HLS system, specifically band 8, which is the near-infrared band, at level 2 processing, was kind of the best bet for me. It gave me images like this here, which as you can see, is cloudy, which is somewhat of a problem of the area I was in, as most of the year was either cloudy or covered with ice and snow. So when I did find a picture like this, I was extremely happy, and I was only able to find a couple of these images per year, so you can imagine how glad I was that I found some of these. And now with the HLS system, I was able to get 30 by 30 meter resolution pixels, which is extremely high resolution. And in the end, I analyzed everything in ArcGIS Pro because I don't think I'd have the coding chops to do this all in Python. So when I did analyze everything into ArcGIS, my first step was to take that image that I got from HLS and use the ISO cluster unsupervised classification, which classified all the pixels into either water and non-water pixels, which is this picture right here, all the blue pixels. Now, to kind of further narrow down what all the water pixels actually are, because this could actually have some false classifications, I use majority filter, which gives me all these green pixels. And even narrow things down even more, kind of get things closer together, I use the boundary clean tool. And as you can especially see kind of in this right-hand corner here, you can see a lot of pixels that were picked out. Now, the ocean was covered in ice, so when I switched over into my polygon layer, I had to kind of cut out that ocean because that would have thrown off my entire analysis. So when I clipped things into the study area, I was able to then merge things by the shape area to get this lovely map with 4 different categories of lakes. Why did I use those 4 categories? I took them all from the Jones study, where it was 0.1, 1 to 10, 10 to 40, and 40 to 400 ha. And 1 hectare, or ha, which I'm calling for short, is 10,000 meters squared, which might seem very large, but in the end, there's very large lakes there. So when I started analyzing all this, I'm like, okay, let's look at 2024. I found some problems. I was missing close to 400 lakes. I'm like, well, is this a me problem? So then I went back and analyzed the 2007 study area using similar Landsat 7 imagery, and I found that I was now missing close to 500 lakes, which is more of a problem. So I'm like, well, if I'm missing so many lakes, what if I go back and analyze the full raster image? Now, this is the full image that I showed you before and not the little clipped study area, and I found that I had, in fact, found over 700 lakes comparable to the Jones study, but things still weren't adding up very well, because you can see my 1 to 10 range is kind of higher than what their 1 to 10 range was, and this really should be more in the 0.1 to 110 range. So I now went back and was like, okay, what if I start to manually count all this stuff? So here's now their study area georeferenced in ArcGIS, and I want everybody to focus on these 6 rectangular areas. So I went and I modernized the nice little study area here, and you see those lakes have now since disappeared. I'm like, well, I know some lakes have disappeared, but I don't think 400 to 500 lakes have disappeared in my time span. So I then manually counted everything to make sure ARC was counting everything, and I personally counted 382 lakes while ARC counted 317 lakes. And the reason why my count might be a lot bigger is because I likely counted a lot of the smaller lakes that ARC wasn't processing. So when I got into my own study, like now I have all this annual change data, I was able to see kind of this undulating pattern, right, in these nice blue bars, which is my 1 to 10 Ha range. And I found that in all actuality, the 0.1 Ha range is not that important anymore. It's not really showing much change, but the 1 to 10 Ha range is very dynamic, because it's showing close to 50 lakes changing per year, which if you think about it, if you all of a sudden have a lake disappear and reappear in every year, that's kind of a serious thing. So I want everybody really to focus on these 3 key peaks above the 200 lake range. So it was pointed out to me by one of my meteorologist colleagues here that I should look at the La Nina and El Nino cycles. I'm like, okay, that sounds great. I don't know much about that, but let's look for it. So when I did look for it, I found that there might be some correlation. As in 2016 and 2021, they were both weak to moderate La Nina years, meaning they were kind of in the cooler range, shown down here with the nice rectangles. But the problem is 2024, we all know we had the super strong El Nino, so that wasn't quite there yet. But then I started looking, well, the year prior can tend to be like, is things melting there too, and kind of really inform these processes. So 2015 and 2023, with the red star and the blue star, are very strong, or strong to very strong El Nino years. But the problem with that is in the 2020 years, so the yellow star there is actually a moderate La Nina year. So even that wasn't matching up. But the idea with that would be potentially to go even further back in time, to 2007 and potentially even further back, to see if the cycles actually hold true and if they really mean anything. But that was not the scope of my study, and I didn't have enough time to really go further into that. So in the end, I had to answer one big question of, why was my study and the Jones study so different? One reason why, our software might be different. The Jones study used eCognition, which is a software I looked at. I'm like, way too expensive for me at this point in time. So I used ArcGIS Pro, which I had a lot of experience in. But the thing with that is we had the same methods. We found an image, we converted our image into water and non-water pixels, and we categorized everything into our 4 categories of lakes. So perhaps it's a different imagery. We use different satellites, maybe things are a little different. The Jones study used the Landsat 7 ETM+, so the enhanced thematic mapper, while I was using the harmonized Landsat Sentinel system. But the thing with that is I did go back and confirm with the Landsat 7 2007 imagery that should be comparable to theirs, and I still found that I had some problems. So, as I proposed before, when I was looking at their graph, maybe it's a difference in area, as in I specifically was staying within the proposed study area, and maybe the Jones study did not. But then with that is I also didn't have good correlation within my lake sizes. So my conclusion in the end of all that is that it is indeed very feasible to monitor thermokarst lake changes, as this nice little animation that I quickly threw together shows, that it is able to do things annually and potentially monthly even during cloudless months. As this could actually see lake drainage events happen, I'd also focus more on the 1 to 10 Ha rate lake size range, as that show the most dramatic and kind of that cyclic nature. And I also want to extremely stress that this could be an indication of where permafrost is melting and how fast it's melting, regardless, showing how these lakes have changed over time and if more lakes are actually appearing. So some future work and key ideas would be to continue looking into more of the lake area change, as the Jones study found that it wasn't just the lake number itself was changing, but actually the total lake area was actually decreasing. So more lakes, but smaller lakes. I also want to expand the study area to the rest of the Seaward Peninsula, as that would really show more of the thermokarst areas and more of the continuous permafrost there. I also want to research more into if the cycles mean anything. You know, if the La Nina versus El Nino cycles actually correlate to these things, or if it's the temperature or the precipitation the year prior, the year of, all these things. And it'd also be good to look into like increasing the resolution of the theory. As well, the HLS system does have 30 by 30 meter resolution. It cannot capture all those smallest lakes, which potentially the ELVIS, so the land vegetation ice sensor, flown on aerial instruments, could potentially do. I'd also propose working with others' ideas, such as automizing this process, as this 2023 study has shown. It is possible to do. And using this, you could look at other thermokarst areas, such as in Siberia, northern Canada, other parts of Alaska, to kind of quantify all these changes together. And I will leave everybody with some key ideas and my contact information for any questions. Thank you.
Well, thank you, Belle. Questions?
This is just more of like a personal question other than anything. Like, why specifically thermokarst?
This was literally just me looking up in my school's library, being like, what is hydroecology stuff? Reading through the different papers, finding something I was interested in, and then looking up some pictures of an area. Because I'm very familiar with lake areas, but then I didn't know, like, I didn't understand like how these lakes came to exist. Because I'm very used to like regular karst, and all of a sudden there's something called thermokarst. So, yeah.
Riley, do you want to get Lisa?
Thanks for the presentation, Belle. So you were mentioning that clouds were getting in the way of being able to like monitor thermokarsts. So if clouds weren't a problem and you were able to view more images, do you think the evolution of thermokarsts every year would be any different from what your results show?
I don't think the annual change would be any different, as I was actually looking at very comparable time spans, as the clouds were actually more prominent during certain time periods or not. I tend to stick between June and August time spans. So while I don't think it would change annually, I think if we were able to look at things at like even an increased temporal scale, we could see like drainage events and kind of see how quick changes are happening.
Thanks.
Great job, Bill. I was just wondering, it seems like the depth of these lakes and dynamics with, the vertical, excuse me, would also be really important for understanding what's going on with the soil melting.
Mm-hmm.
So I was wondering if you could comment on how that could even be assessed and what trends you would expect to see there over time.
Yeah, these lakes tend to be fairly shallow in themselves, but I do know that with increased precipitation, they tend to increase in depth as expected. And I don't think we could really see that like via satellite. So I think that'd be more like in situ measurement time and like ground truthing it to understand how that is all changing. I think that would be necessary.
Hi, Belle. I'm Kelsey Bisson. I wanted to congratulate you on a great study. And also, when I was thinking about this, it got me thinking about statistical relationships and how looking at power law of the size distribution of these lakes could be a really powerful tool to describe them and kind of collapse the variability into a single parameter. And then perhaps, despite, as you mentioned, there are remote sensing limitations for getting the smaller lakes, if you would expect a relationship to emerge, it's maybe less of an issue that you can quantify for the bigger stuff. And then when you see departures from that kind of relationship, it might imply something has changed in a more significant way. So just a comment to say, I really liked learning about your study and it might be an area for future work.
Yeah, I think it's a very big area of study right now, but I don't think many people are researching actively in this specific area, so.
Other questions? I'll throw a last one in here. So with these thermokarst lakes, what can you say about when they appear or disappear? Do you know anything about like what the impact that has on the ecosystem up there?
Well, the fact themselves is that these lakes tend to be freshwater, so they tend to create a very nice freshwater source for, say, flora and fauna. Now, these are all in very low fauna areas, as these are in the tundra and kind of very cold areas. But they do hold some ecological impact, especially when they drain, because they tend to leave these, I wouldn't say huge craters, but kind of large divots in the ground that kind of can further degrade further and like landslide off the sides and kind of cause runaway effects of like how like changing the landscape happens. So they do have, I wouldn't say serious ecological impacts, but they definitely have some.
Wonderful. Anyone else? Anything online? Negative. All right. Thank you so much, Belle.